Hi, my name is Senthil Annamalai. I'm a Senior Staff Product Engineer at Synopsys supporting extraction products. In this video, I'm going to cover the applications for StarRC's resistance extraction capabilities. StarRC currently supports rule-based mesh and field solver approaches for resistance extraction. Traditionally, capacitance was the main extracted parasitic element, and technology for capacitance extraction progressed rapidly. Resistance extraction was done primarily by rule-based techniques since metal traces only supported 90-degree turns. Recent advancements in silicon process technology and 3D IC packaging, all angle and curve traces are possible. To support all angle trace resistance extraction, mesh technique is required, and for curve trace resistance extraction, field solver is needed as shown in the image. In the rule-based approach for resistance extraction, the extractor first decides current direction based on heuristics, and then along the current direction generates nodes and connects them by resistors whose values are calculated by RPSQ times L over W, where RPSQ is the resistance per square for the layer in which the resistance is extracted, L is the length and W is the width of the polygon. This approach is accurate enough for long rectangles whose current directions can be easily decided and widths are uniform. Rule-based approach is not accurate when length over width or aspect ratio is close to 1, so it is hard to decide the current direction. This is especially true and more complicated when designs have non-Manhattan shapes with holes. Mesh-based extraction is targeted to improve resistance extraction accuracy on complicated slotted metal layers where current flow is difficult to determine. Target layout condition is PG mesh extraction with plenty of slots and multiple layers. The standard mesh resistance analysis might require longer runtime than standard resistance analysis, and the netlist size increases due to the larger number of resistance nodes, which also impacts the subsequent simulation runtime. User may use parasitic reduction option to mitigate the above effects. The resistance field solver or RFS uses a refined mesh analysis approach for resistance calculation to provide accurate resistance extraction for any shape of geometries, including non-Manhattan shapes with many holes. To allow resistance calculation of planar arbitrarily shaped geometries, a 2.5D meshed approach will be used. For a 2.5D mesh, a single plane of resistive elements is created in the XY direction for each metal layer. Contacts in the Z direction are then made to the mesh with additional resistors in the Z direction only for vias. 2.5D simulation runs much faster than full 3D since the number of nodes is much smaller. User can choose specific nets and/or layers for RFS to extract. Ports provide connections between the RFS and the outside world. There are options that control how to model ports, specify the mesh size, and also to refine the mesh. Various modes of production are supported as well. Process models including edge and thickness variations as well as various resistivity models are accounted for in RFS. StarRC is the golden sign of extraction tool with renewed focus on features for custom design. With the addition of resistance field solver capability, it can support accurate resistance extraction on custom designed traces found in display driver ICs, automotive chips, and 3D ICs. Thank you for watching this video.